In this lesson, we are going to learn how to use Three.js lights. And we've been using lights already. In the previous lesson, we used the ambient light and the point light. But we have so much more to see about lights, and we are going to see all of this right now. So adding light is as simple as adding mesh. You just have to instantiate the right class. So we will discover those classes and add it to the scene. So don't forget to add to the scene, which is a classic mistake. So yeah, about my setup, we have our a sphere, a cube and a torus, and a plane that served as the floor. And we use the same material, as you can see here. I have only one material, which is a mesh standard material on all objects. All right, we have the different roughness. It's just to enjoy the light and have a good looking scene. You can tweak it if you want, but I recommend to use the same tweaks as me. Okay, let's go. We are going to remove the ambient light and the point light because we already have those in the scene, in the code, which is right here. Those point lights and ambient lights come from the previous lesson, but we are going to rediscover them and see more detail about that. If you remove those lights, you get a dark scene because the mesh standard material needs light, so we can see something, which is physically correct. All right, let's see those lights. So the first one we already saw is the ambient light. So we are going to do it again. To instantiate the ambient light, you use the ambient light class. You have examples available as always in the documentation. Const ambient light equal new 3 ambient light. The first parameter is the color. And the second parameter is the intensity. If I just do that, as you can see, nothing, because I forgot to add it to the scene. Scene add, and my ambient light. Oh, that's not it. Scene add, my ambient light. And now it's working. So as you can see, it's quite strange. The idea behind the ambient light is to have omnidirectional lighting. It comes from everywhere. All the rays come from everywhere. It's uniform, and you get something like this, which looks more like as if we use the basic material. So we could have said that it's not realistic, so it's not useful, but actually it can be really useful as we are going to see. One thing to say about how to instantiate all the lights we are going to see now. A little like the materials, you can instantiate by sending the parameters in the parentheses right here, or you can remove those and set the parameters after. So we have the color. If you remember from the materials lesson, a color has to use 3 color class. So it's going to be 3 color like this, and you can choose a color. So I'm going to use the same one, which is just white. And you can also change the intensity, which is the second parameter, which is intensity like that, and put the value. And as you can see, I have the same result. All right. Choose the version you prefer, the way you prefer. You can do it in the parentheses when instantiating or after. I think in the rest of the lesson, I will use right inside of it. So let's get back to the first thing we had, like that. And this is the result. So I'm going to do a lot of drawings to help you understand all of this. And this one is quite simple. Let's imagine we have our scene from the side, like that. The ambient light will simply apply rays from every direction like this, which is why we get something very uniform all around our sphere, our plane, our cube. Okay? If we had, let's say, a crevice, I don't know, a shape a little strange like this, with the same floor, we would get the same result. Like, it's not like if the ray come from here, it works, and if the ray come from here, well, it doesn't work. No, it doesn't work like that. Every part of the mesh will be lightened up, will be illuminated the same way. All right? It's uniform. We can use those. Oh yeah, we can add to the debug. We are not going to do that a lot because this is not the point of the subject of the lesson, but you can do it. I would just show you how to do it once again so you understand really how it works, but we will only do it for the ambient light. If you want to add the ambient light parameters to the tweaks, to our debug panel, what you need to do is GUI, add, then you have to choose the concern object, which is ambient light in our case. And the second parameter is the property, and we are just going to test on the intensity property. And then you can set a minimum value, a maximum value, and a step. The minimum value is going to be 0, the maximum value is going to be 1, and the step, you can put anything between those. So I'm going to use 0.01. And as you can see, I have control over the intensity of the ambient light. All right? Feel free to do that for other lights. We won't be doing it because we need to progress, but it's good to practice. So it's up to you. All right. I will remove it, but you do as you want. So yeah, why ambient light can be used for, and it's exactly what we did in the previous lesson. Maybe you haven't noticed, but it's good to simulate light bouncing, because a little later we are going to have, let's say, another sphere like that. I'm going to draw a circle. We are going to lighten things, let's say with the light right here, and the light is going to launch rays like this and illuminate this part of the sphere. All right, this is true. But in real life, we can see the back of the sphere, because the light can bounce and jump back to it, bounce and jump back to it. All right, this is why we can see behind things when we have even just one light on an object. You can see behind because light bounces everywhere. Light bouncing is very hard with a 3GS, with a real-time rendering, whatever the engine. What you can do is just use the ambient light. So the light we only apply like that. And to simulate the bouncing, you will apply a small dim light from everywhere. And you're going to use the same color. And it will simulate loud bouncing with just small dim light. All right, it can be used for that. And we're going to use it this way, at least for now. Okay, cool. So we have our dim light illuminating our objects from everywhere. The next one is going to be directional light. And directional light, we can instantiate it like this. It's a very interesting one. We can do directional light equal new 3 directional light. And we are going to choose a different color, which is this one. You can choose your own colors, but I'm going to use the one from my examples. And don't forget to add it to the scene. Scene, add, directional light. And we get this. So it seems that there is a light coming from the top, because as you can see, all we have in the bottom is the ambient light. But from the top, we have like a blue light illuminating the scene. And this is true. This is what's happening. The directional light works just like this. So let's continue on our row. We have something like that. The directional light will apply a light, but with the rays coming from the same direction, like this. And they are all parallel, like this, all right? And it goes up to our meshes and just illuminate the specified part. If it's on the side, which is the case like right here, we cannot see much. If it's like on this side, it will be much more visible, and on this side, not much visible, and this part, we have nothing, right? So yeah, it's like the sun. The sun, we interpret it like this, at least. It's the rays are going parallel to the earth, and we get this effect. So yeah, about the parameters, we have the color and we have the intensity. If you want to add those to your debug panel, please do it. But what if we want to change the orientation? It's a little strange, but you will get it, don't worry. We have to play with the position. So if I change the position, I'm going to use the example from right here, from the lesson. I'm going to use those settings and you will understand what exactly is happening here. So it's going to be 0. And now it's coming somewhere from the right part, right here, which is exactly what I have here. But it's a little strange. The idea is that by default, the rays are coming like this. All right, it's a fact. By default, it's like that. When you want to change the orientation, this is the center of the scene. This is my light. I'm going to use another color. And if you put your light, let's say, here, the light will illuminate the center of the scene. So the ray will do like this, and like this. All right, it's the position, which is like positioning the sun, and then all the rays come from that direction, from this position in the direction of the center. All right, if I move it there, like this, all the rays will do that, that, and that. Cool. So we put the light on the right, and then it does something like this, from the right to the center of the scene, which is why we get this result. And you know it's on the right because the first value is 1. Positive x is the right of the scene. It's that part. Okay. Yeah, the distance doesn't matter for now. If you put it like right here or right here, that doesn't change anything. Later we will see that there is a difference in that. It's going to be when we are going to use shadows. But for now, no difference. You can put it right here or right here. The rays are going to be like infinite. And we do like that. They come from the infinity and goes to in our center of the scene. The next one is the hemisphere light. Very interesting one, and you can get really cool result with this one. So we are going to add it. It's going to be hemisphere light. Sorry, I say sphere, but it's sphere. Equal new 3 dot hemisphere light. Be careful with uppercase, lowercase. It's Pascal case. You can choose a color. I'm going to use red, and you will see that there is something strange. We can choose another color. I'm going to use 0x0000ff. So if you remember hexadecimal, it's going to be red, and this one is going to be blue. And we use the intensity as a third parameter. And we are going to see what we get. We do scene add. As always, don't forget to add it to the scene. And we get something like this. And there is a lot happening here. If you remove the other two, so you can just command the scene add, look at this. It's not, we cannot see much. I can just crank up the intensity. We have blue from the bottom and red at the top, and in between we have something like purple. So I get back to my previous values. I think you understood, but anyway, I'm going to explain. So let's do one huge thing like that. This is my sphere. If I choose as a first value red and the other is going to be blue, red will be applied from the top, and blue, I don't have blue, too bad, it's going to be purple from the bottom. So you get illumination that works like this and illumination that works like this. And in between, you get a mix between those. So on the top, you will get like something really red, like this, and a little less on the side. I'm going to do the same on the opposite. So it's red, 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 and less red. And from the bottom, you get purple and less purple. Purple and less purple. So you get a mix between those two colors. And it works like the ambient light. It comes from everywhere. All right. Even if there are crevices, every faces will be illuminated. All right, and that's all. So this one can be really useful if you have like a grass on the floor and the sky is blue. You will use green here, blue here, and you will get a really cool result on your object. It will look like the light is bouncing, just like I explained to you, but with the right color, which is great. You can have realistic result with that. And it's cheap in terms of performances. The next one is a point light. So it's kind of self-explaining. We are going to instantiate it anyway. And I think it's the one we used right before. New 3-point light. We're going to use only two values here. It's going to be 0xFF9000 with an intensity a little higher than the rest. And don't forget to add it to the scene with scene, add, and the point light. And we get something like that looks like a point light. Like if there was a point, like a lighter right here, illuminating all around. We have a lot to say about this point light. So yeah, I'm going to draw something as always, because drawing is a good way to learn. So we have our light, let's say it's this one. The light position is right here. This point is infinitely small, all right? It's not like a light bulb. You don't have something that look like this, all right? It's not that. We have an infinitely small point, and these points will illuminate in every direction like this, all right? So this is why our objects will get a lot of light if the face is facing the light, and if it's not facing, well, it's going to dim like this. All right. We can change obviously the position. As you can see, I position, it's not the center of the scene, I put it somewhere else. So we can change the position by using the position property, which is cool. It inherits from the object 3D, so we can use the position, and we can use the set and do like we did in the lesson, which is 1 minus 0.5, 1. I don't know why I put those values exactly, but anyway, it's going to work. Oh yeah, it's to have the light very close to the floor, so we can really see that, yeah, there is a light here. We cannot see the light, but we can see the objects all around the light being illuminated. So it's right here, and we get also the reflection on the mesh standard material. All right, there are other parameters for the point light, which is the distance and the decay. And we can control, the distance is like the fade distance. By default, I'm going to draw something else again. So we get our usual sphere, like that. If I have a point light somewhere, let's say like this, currently, if I have my object here or here, the light strength will be the same, all right? If it's here, there will be this light strength. And if the face is here, it will be the same strength, all right? With those values, I can control the decay and the distance where the light doesn't work anymore. I can control that in, I don't know, maybe 10 units, the light will be dimmer here. So here it's very strong, very strong, very strong, and it gets less strong until we have nothing. And if an object is too far, we cannot see that object, at least it will not be illuminated by this light. And we can use it, you can just put values. We can use the distance. So if I do a very small distance like 1, we get strange result. Yeah, it stops at 1. So we have 0 here, so it's the point light. And at 1, it doesn't work anymore. So every objects are too far. And we can do a little more, like 3. And it starts, oh, sorry, no, it's not this one, it's this one. So the cube starts getting illuminated, the torus a little more because it's closer, but the sphere doesn't get any light from that light right here. So it's working. So we have this, which is the distance. After this distance, it doesn't work anymore. I can choose 10. And the decay is how fast the light decay. All right, cool. The next one is really cool, like really beautiful. It's the rect area light. So we are going to use this rect area light. Let's instantiate it. New 3 rect area light. As again, we choose a color. I think it's something like look bluish. Yeah, kind of purple maybe. And I'm going to put the parameters and we are going to explain those. Don't worry. The first parameters, you know them. It's the color and the intensity. So if I crank up the intensity, the light will be stronger. We don't forget to add it to the scene. So scene add rect area light, and we get this. The rect area light, it's like on the photo shoots. The idea, I'm going to draw again. I like to draw. So this is up when you set. So we have our sphere. It looks like this. And the area light, it's like having a rectangle like this. Like on the photo shoot, you know, we have something like that. And it's a plane. And this plane will illuminate in a direction, but kind of in other direction too. So it's going to be dim a little. So it's going to do something like this, like that, in a direction, but also kind of diffuse too. And you get something like that. And our object might be illuminated if it's in the right position, like that. So what we get right now is this result, which is kind of strange. What you can do to understand a little more, it might be to just command the other light, and we get a cool result. I really like this one. I like how it's looking. I don't know if you can see much in the video, so just try on your computer. And if I crank the intensity up, I can get really cool result like that. The third and fourth value are the width and the height of this plane right here. So it's the width and the height, like that. We can control those and put other values, like, I don't know, 3 maybe. As you can see, it's larger. Right now, my plane is through my scene, all right? It's in the middle of the object, which is why we get this really strange result, but I think it looks really cool. You can do a lot of cool stuff with that. I'm going to get back to my previous scene by getting back my lights, and we are going to change a few things about this light. One good thing to know is that rect area light only works with mesh standard material and mesh physical material. So if you want, don't do it, I will just show it to you. If you test with mesh foam material, as an example, as you can see, all the lights are working, but the rect area light. Yeah, so be careful. If you want to use this one, you have to use mesh standard material or mesh physical material. And mesh physical inherit from mesh standard material, which is why we can use it too. So how to position it? First, we can move it. All right, we're going to move it, I think, somewhere in the floor. So to move it, where is my light? It was somewhere here. Yeah. We can change its position. It's going to be minus 1.5, 0, 1.5. Let's see where we get it. Oh, sorry, always this thing. Thank you, the suggest, but it's not what I wanted to mean. So we get something like this. So it's inside the floor, I think. Yeah, it's probably that. And now if we want to orientate it, it can be a little harder because you have to calculate the orientation, stuff like that. So if I want to orientate my light to the center of the scene, maybe I can do like trigonometry, tangent, sinus, cosinus, stuff like that. Or, because it's an object 3D, I can use the look at method. Look at this, you do look at, do it after changing the position. Because if you do it before changing the position, first you tell him to look at something and then you move it. It's not going to look at this thing. So first you move it and then you tell him to look at something. So you use the look at method, and you can provide just a new 3 vector 3. And when a vector 3 is empty, it's going to be 0, 0, 0. So it's the center of the scene. And if I put my camera up, as you can see, this is my rect area light, and it's looking at the center of the scene, which is somewhere over here on the plane where my cursor is right now. So yeah, you can use look at. Look at is really good if you want to orientate things. The next one is the spotlight. The spotlight is quite easy to understand. It's like, how do you say? It's like a flashlight. That's it. Sorry, I lost the word. So I'm going to do the same. It's going to be, this time it's not going to be that. I'm going to create a wall. because the word will be easier to understand. This is going to be my spotlight, so it's going to start right here, and it's like a flashlight. So we get something like this. This is a flashlight. And your flashlight will illuminate, I don't know, something like that and that. So we don't care, it's above. And we will get a circle on this part. It's like a real flashlight. We get a circle, and we have to talk a little more about what we get exactly here. So let's instantiate it. I'm going to call it spotlight, new, 3, spotlight. It's gonna be something like green, and we have a lot of parameters. We are going to explain those. The first one, you know them, it's the color and the intensity. And the other one, we don't know much about them. We are going to talk about these, 0.1, 0.25, and 1. And we are going to move it right away. Zero to 3, and we add it to the scene. Like that. And we get a spotlight illuminating the center, so mostly the cube. And the spotlight is somewhere above, like if I put my camera is supposedly right at the spotlight position, somewhere like this, and it's illuminating our cube, and we get something like that. So it's a round, but because of the position of the spotlight, we don't forcefully get like a round shape, illumination shape, and we get something like that, which is great. So what are those parameters? First, you have the color, then the intensity. This is like the previous lights. If you crank up the intensity, we see that the light is brighter. All right, we get a very green and bright light. The distance, well, you can just lower the distance, let's say 4, and you see that it faded too fast, so let's try something else. Let's say 7. We can see it, and as you can see, we can barely see it at the edge. If I put 6, look at this, we cannot see it here, but if we get closer to the spotlight, we can see it. So it's just fading with the distance. Here we get something really strong, and the further, the dimmer, and we get something like that. Okay, cool. The angle, well, it's the how wide is your light? And I use MathPy because it helps me. I know that math is half a circle, so I can just write something for you, draw it for you. So if I use a MathPy, I'm going to have a very large spotlight, which will do something like that and illuminate everything around here, which is a lot. I use 0.5 multiplied by MathPy, so it's going to be 0.5 of this large angle, 0.1 of this large angle, and we get something, I don't know, maybe like this, 0.5 of half a circle. We get this angle right here, this value here. So if you want a larger, you can do 0.2, sorry. As you can see, it's really large. You can see the shape of the light here. And if you want something really strong, you can just put a 0.05 maybe. As you can see, it's not strong, small, and we get a small light, and we can even see the shape of the light on the cube. All right, use the value you want. The penumbra is going to be the dim on the edges of the shape. It's going to be over here. What's happening here? If we have no penumbra, like we use 0, I'm going to test 0, you will see that, oops, it's not going to like it. Yeah, you can see that it's sharp. You see here, it's sharp, meaning that when if the object is in the light, we can see it. If not, we cannot see it here. And if you use, I'm going to use another color, let's say a red one. If you add penumbra, this part will get blurry, see, at the edges. So we added 0.5 and you will get a penumbra by using that. As you see, it's dimmed, it's fading on the sides. And finally, the decay, it's like the decay from the point light. It will influence how fast it goes to the limit. So if I use, I don't know, 0.1, we'll get something different. But at the end, it just, we cannot see it. So this one, usually we don't play a lot with this one. I usually just keep 1, all right? Okay, cool. Yeah, and as always, we can rotate it, but this time it's going to be different. We have to use the target. And if you look at the target of the spotlight, I'm going to log it. You will see something very strange. We cannot just orientate by using the quaternion of the rotation, and we cannot just use look at for the spotlight. It works differently. I don't know why, but it works differently. You just have to know how it works. If you log the spotlight target, you will get something strange. It's an object 3D. It's not a vector 3, it's an object 3D. The spotlight will look at this object. So you might thought, maybe you can just change the position and use something like minus 0.75 on the X, position X 0.75. It's not working. This target object is supposed to be somewhere like here, but the spotlight is still looking at the center. Maybe if I do more, 2.75, no, it's still not working. And it's normal. It's because our target is not in the scene. We have to add that object. Imagine that the target of the spotlight, it's like an object. We cannot see that object. It's purely theoretical, sorry. And if we don't add this object to the scene, well, there is nothing to calculate. So we have to add this object to the scene by doing scene, add, spotlight, target. And now it's working. As you can see, the light looks on the left, right here. And if you increase this value, you will see that it's looking even further on the left. All right, this is strange, I know. I don't know why it's working like that, but at least we know it and we can adapt. Yeah, let's talk about performances. First, you have to understand one thing, is that lights can cost a lot when it comes to performances. If you want to create, I don't know, let's say a full village at night with torches and lights, street lights, stuff like that, maybe you will try to add hundreds of lights. It's a really bad idea. You will have a performances issue and you will even reach a limit. And I think it's something like 50, something like that. You cannot put more. It's a bad idea because it will cost too much for the performances. The idea is just add as few lights as possible and try to use the lights that cost less, because there are lights that are easy for the computer and lights that are really hard for the computer. The minimal cost lights are the ambient light and the hemisphere light. These are okay. It doesn't cost a lot. The next one is with moderate cost is the directional light and the point light. Directional light and point light has moderate cost on performances, and spotlight and rect area light have a high cost on performances. So be careful with those. Don't add too much of them. It will cost too much on performances. 1, 2, 3 depends, but not too much. Yeah, we can talk about baking. When you really need to have a lot of lights and lights that looks just perfect and with the light bound stuff like that, maybe you cannot do it inside of Three.js. Maybe you need another solution. There is a solution named baking. The idea is to bake the light into the texture, and you will have to use, or it's not necessarily, you don't have to use a 3D software to do that, but it's usually better in your process. But you are going to use a 3D software to bake the light inside the textures. Maybe you don't know exactly where I'm going. I'm going to show you examples so you can understand. The drawback is that we cannot move the light, because the result of the light will be baked inside the textures, and if the lights move, the textures won't be updated. I can show you an example, and you get a lot of textures to load, obviously. One good example, so it's going to be the coming soon of Three.js Journey. But if you click on this link, you will get the homepage of Three.js Journey, which is almost the same. We get the same experience. If you look at those lights, you can see that it's really realistic, and we get beautiful shadows. We get light bouncing, which is why this part is a little orange. See, it's all burned inside of this part. Like, it looks really cool. We have light bouncing everywhere. there is actually no 3GS light right here. It's just baking. I baked the light and also the shadows inside the textures, and you get something that looks like this. This is the texture with all the lights. As you can see, you have shadows, light, illumination all around. You can see that this is the carpet, and everything is put inside the texture. So we get beautiful lights, but we have textures to load, and this can be really heavy. So you have to find the best solution. All right, the next step is about helpers. Let's use the helpers. So the idea is positioning the light can be a mess. Like it can be really hard because you cannot see the light. All you see is the effect of the light. To help you position the light, you can use light helpers. And if you do helper on the 3GS documentation, you get a lot of helpers, and you see that there is a point light helper and other light helper right here. And we are going to test those helpers because we are going to have few troubles. So this is the base lights. I'm going to do helpers just inside right after the lights. You can do as you want for the commands. And we are going to use the first three, which are pretty easy to use. So it's going to be long name, but you can do whatever you want. Hemisphere light helper equal new 3. I'm going to use the class hemisphere light helper. So I use the same name, which is why it's that long. And when you use a light helper, you have to provide the concerned light. And for me, it's the hemisphere light, because I have a hemisphere light at the beginning of the code. And the second parameter, you will see, let's use 0.2 and add this to the scene. So scene add my hemisphere helper because it's visible, and we get that. The second value, I don't know, let's put half of the value. It's the size of the helper. All right, I have a very small prism right here. If I put 2, it's going to be twice as big. And we get something like this. And as you can see, it's blue at the bottom and red at the top because the colors of my hemisphere light are red for the top and blue for the bottom. That's all, I can just use it. So it's not really useful to use an hemisphere light helper because light comes from everywhere, but still we have access to it. The next one, where is it? It's right here. It's going to be the directional light helper. This one is much more useful, directional light, and we are going to use it in the next lesson. New 3 directional light helper. Like for the hemisphere light, you have to provide the concerned lights. So for us, it's directional light. If you called it like sun, you will use just sun. And I'm going to use the same size and add it to the scene, like this. And I get my light. So this one is slightly different. It's a plane. It's just to represent it. And as you can see, it's illuminating the center of the scene. And yeah, it's blue seeing from here. And the lights come from the infinity behind the scene at the right and traverse the scene like that. Next one is the point light. Counts a point light helper equal new 3 point light helper. And as always, we use the point light because it's the name of my variable. I use 0.2 for the size, and I just have to do scene add point light helper. And this is my point light. It's right here, right above the ground. Very useful. As always, it's just for positioning. Once you're done, you can comment everything and enjoy your scene. So what about the other ones? We have access to spotlight helper, which has no size, so it's slightly different. So let's go. Const spotlight helper equal new 3 spotlight helper. And I use the spotlight as parameter and nothing about the size. And as always, you add it to the scene. Scene add spotlight helper, and that's it. Oh wait, there's a problem. This is the illumination created by the spotlight. So if I refresh, it's on the left. But look at the helper. It's not at the right spot. So if I move it even more, don't do it just to show you that. This is my spotlight. It's the target. If I use 1.75, so see, it's illuminating this part, but my helper doesn't update. We have to update it manually. There is something happening here. I don't know what exactly. Maybe by the time you test it, it's going to be fixed, but there is maybe a bug. I don't know if it's a bug. To me, it's a bug, but you never know. We have to update it. And to update it, we have to do Spotlight Helper update. But if we update it on the same frame, it's not going to work. So we have to do it on the next frame. And we know how to do something on the next frame. We have to do Window, Request Animation Frame, which will call this function we just provided on the next frame. And on the next frame, we can now use Spotlight Helper update. And now it's working. As you can see, it's lighting up, it's oriented in the right direction. Cool, very strange, but cool. The next one is even worse. It's the rect area light. So remember, it's this one. It's the rect area light. From here, it's this one. All right, it's right in the floor. So we are going to add the helper. And the first problem we have is that the helper isn't part of 3GS variable. So if I do at the top 3.rect area light, I get nothing because it's not inside of it. We have to import it from the examples folder inside the node modules of 3GS. To do that, we can do just like we did for the orbit control and do import rect area light helper from, follow me on this, it's going to be 3 examples JSM helpers rect area light helper.js. All right, let's log it. And now we have access to the constructor, to the class that can handle this helper. Okay, not easy at all. Let's add it. So it's going to be right after the spotlight. I'm going to do, this one is rect area light helper equal new. And this time we are not doing 3 rect area light. It's going to be just rect area light helper because we imported just this class as it is. So it's going to be there. And you can pass the rect area light as the parameter and add it to the scene. Scene add rect area light. So we get our rect area light, but as you can see, it's in the center. Oh no. Yet again, we have to do more work in order to get it at its right position. Maybe you think we just need to update it like we did for the spotlight. So let's try to do this. I'm going to do window request animation frame rect area light helper update. Let's see. Yet again, it's not working. We have to do something else. We have to update it manually. So I don't know why exactly we passed it here. It took the color, which is already good. Thank you. But we also have to update its position and rotation ourselves. So let's go. We're going to do rect area light helper. So we are updating the helper position and rotation. And we can do something like position X equal and use the rect area light position X and do the same for the other. But wait, there is a better way of doing this. Okay, let's just test it. And now it's working finally. So it's going at the right position. We still have to do the rotation, but let's talk about the position a little more. When you have to copy all the values of a vector 3 into another, and it's working with vector 2, vector 4, and many other classes actually, you have access to a copy method. To do that, what you can do, so I'm going to comment this, I'm going to do rect area light helper because this is the one we want to update. It's going to be its position, and I'm going to do copy because it's a vector3 that has access to copy method, and pass the vector3 he needs to copy values. So it's going to be rect area light position. So this position is going to take all the property of this position. If I remove this, I can test, and as you can see, I get the same result. All right, you can copy vector3 values to another vector3 just like that. And finally, we need to do it for the rotation. Instead of using the rotation, we saw that it's better to use quaternion. We don't need to understand much about quaternion, we just need to copy the values. So you do exactly the same. I duplicated the line, and I'm just going to replace position by quaternion, like this. And that's it. We have our rect area light that looks like this. Okay, cool. So we understand more clearly what's happening in the scene and how to position things. Once you're happy with your scene and where the lights are, you can remove the helpers and you get a nice scene. Okay, cool. Yeah, in the next lesson, we are going to talk about shadows, because now that we have lights, the problem is that we are supposed to have shadows everywhere and it's not working, and we are going to see how to activate those shadows. See you in the next lesson.